All right.
Let's go to Gus.
Yeah. Thank you. How's everyone doing so far in the class? Okay. Anyone getting allergies? Like, as it just, I feel like there's a cloud in front of my face. Like a fog, yeah. It's so I might be a little. That's what it is. If I look, a little off. Anyway, okay. Let's get. I might check that out at the break. Okay. So I'm going to start presenting, and we will get right into week 6, module 4. It's JavaScript. And first introduction. Hi, I'm Gus. Full name is Augustin. I'm Cost is my last name. I work at Density. I work in that corner of the building. You might be able to see in if you walk across the plaza. There's a couple of desks. They've also just started like a new factory in the back. So sometimes people are down there. I do a lot of JavaScript, less than I'd like, and probably more Python than I'd like, but I do both of those a lot. This week we're going to do the first week of JavaScript. What I've heard is that some people are a little, have gotten into it a little bit, and some people not. So I think there will be something for everyone, but like definitely I'm trying to get a read this first day, like where people are at, what we should go for in 1 week, and then there will be 3 weeks after. And then there's more Java. There's just everything from here on is going to have JavaScript involved in some way. But these are sort of the weeks where we're just going to be talking about the language itself and getting familiar with it. Later on, I will be back to do a module about databases and SQL. SQL is its own language, but some of the database stuff we'll be doing is very similar to JavaScript in ways. And then after that, there's one more module on like operations, like putting servers up on the internet and troubleshooting stuff and designing stuff that's performant and it will scale. So that will be later on. Okay, this is the section we get into real programming. It's none of that fake, and I'm joking. This is not real programming. This is a different kind of programming we're getting into. Okay, it's actually called imperative programming usually. It's something that is very different in a way. It's something you might be familiar with because you probably have tried it, tinkered with it, done it in a little school. But what it is, you're telling the computer what to do, exactly what to do. You're saying, here's a list of things that you should do. And the computer does the list of things in the order you give it. This is different than declarative, which is very similar to what you've been doing with web pages and HTML, which is when you tell the computer what you want. So it sounds kind of similar, but it's very important that it's different. When you're telling the computer what to do, you're actually saying like, giving it a sequence of things to execute, and those get translated all the way down to the lower level. When you're telling the computer what you want, you're describing the end result of all of that. You're saying, well, do whatever you have to do, but now I want to see a list here or a button here or whatever. So HTML is declarative and it's markup. It's actually not really programming because you can't make a lot of things happen. You can sort of make a layout. You can make, but it's hard to make it interactive. So it's a lot of ways to say I would like a button here. I would like a list here. I would like a header here. You're declaring what you want. So again, declarative programming. It's like you have a spell book and you have a wand and you say Wingardium Leviosa or whatever the spell is, and then poof, the button appears. You have to know the particular spell, but it's instant. You just get whatever you want. Imperative programming is like, a recipe or a set of instructions. You're going to basically say, step 1, do this. Step 2, do this. Step 3. And at the end, you probably might have a button or a list or whatever, but there's a whole lot more involved than just the magic words. So JavaScript it's imperative, it's dynamic, and it's a scripting language. So we'll go into sort of what all of these mean. but you hopefully are familiar with the first one. Imperative is different in order. That didn't make any sense. Anyway, it's for making web pages and other things. Do basically whatever you want. It's Turing complete. This is a very important principle in the science of computers and the theory of computers. Basically, Alan Turing proved a long time ago that a particular kind of machine or anything that could simulate that particular kind of machine can, in theory, if it's big enough, compute absolutely anything that any machine can compute. So JavaScript is such a machine. HTML is not. So why does the distinction matter? Declarative languages are really good for getting something up very fast. If you're working with them and you know what you're doing and they fit the task you're doing, it is like being a wizard with a spell book or a witch with a spell book. It's like you say exactly what you want, you get it, you move on. No time wasted, very quick. But sometimes it doesn't produce exactly what you want. Like there's a little change that you'd like it to be a little different, but the spell wasn't designed in that way. Sometimes it's easier to tell the computer exactly what it should do instead of just hope that there's a way to modify the spell. It's often more work than if it's ready, but you have a lot more control. Okay, another way to think of this, in HTML, when you place a piece of code, you have a button, you have a list, you have items that are in an order, let's say. They correspond to the space, the actual place you see them on the page. So if you put one item above another, you would see it above the other item on the page. In JavaScript, when you place some code above some other code, that means it's going to happen first. So the time is when you read down the page, you're not reading down an actual page, you're reading down in time. So what that means is, because you have that dimension there, JavaScript is usually used for interactive, make things happen, make things change, respond to what the user is doing. And that, you saw that if you saw that session with Jeff, where he was making the tip calculator on the page, there was all the elements that were placed on the page with HTML, but then there was all this like sort of code that was just run, to do this and that. And it was added basically to cause different things to happen in different situations, and that's how you make it interactive, and that's how you change things on the page. Okay, that's a lot, but there's more. There's another kind of a paradigm called functional programming, which we'll probably get into a little later. And it's sort of a weird hybrid. When you do functional programming, you're describing a sort of thing that should happen in a different situation. Like given one situation, here's what should happen. Given another situation, here's what should happen. You're not saying do this, do this, do this, do this in order. You're just kind of describing some kind of response or some kind of result of each situation or input or whatever. It can be similar to declarative programming. You can kind of still have more control because you're not just using like a predetermined set of things you're allowed to declare. You're sort of declaring behavior. It's very hard to think in this way. I don't expect anyone to be like, oh, I get it. Like, don't worry about it. We're not going to get into it, but. Yeah.
I mean, it takes a lot to think about it in order to.
Yeah, it's something it's not natural. It's not a natural way of thinking, but it's something that allows you to make programs where you don't lose track of what's happening. The problem with like just doing first, second, third, fourth, fifth is it just goes on, and you're going to lose track eventually of where you are, what happened before, what happened after. And this is sort of a different way to break it up so that you can look at each individual piece of like behavior in a way that's more designed for maintainability or understandability. Again, given like a lot of practice. So that's just a preview. Okay, let's do a demo. Does anyone know what the JavaScript console is? Okay, cool. I will also show you the JavaScript console. If you don't, you haven't seen it. Oh, I'm already in Chrome, right. So let's figure this out. So let's go to, google.com. And if you go to any web page in your browser, are people using Chrome? Is anyone not using Chrome? Okay. So if you're in Chrome, you go to your any web page, you have a JavaScript engine running in this web page. Every web page has JavaScript, pretty much, unless you turn it off on purpose. Some people are like paranoid and they're like, I don't want to run any JavaScript, so they turn it off. But everybody else, if you're not aware of it, you have JavaScript program that can run in every single web page. And the way that you get to that and interact with that on the live web pages, you do the JavaScript console. It's wait a minute. Let me pull up the actual slide. It's the next slide. You do Command Option J in Google Chrome, which I'm already in again. Okay. Command Option J. So this here brings up this console. I don't think this top section will be appearing, but it's like extra settings for the console. You can, oh, this one I don't think is default. That one's very cool. Okay, so this is a JavaScript interpreter right here. We can say 1 plus 2, just like a calculator, and we get 3. Is that big enough? You don't have it.
Well, no, I got a page full of errors.
A page full of errors. You're on a different website.
I'm on Chrome.
Right, but that website has some errors. It's no big deal.
Oh, okay,
At
that's.
the bottom, you can still type stuff in. So it's just telling you that certain requests or whatever are erroring.
I was
JavaScript
just saying, it didn't look.
JavaScript in general was designed to keep running no matter what. So there's a lot of errors. It swallows a lot of errors. It just keeps on chugging along, and that can actually be a problem because sometimes you'd want it to break. You'd want it to like say this is wrong, and it doesn't. It just it's going to show a lot of errors if it can't download something or in a lot of cases. Anyway. So this here is what's called an interpreter. You're basically typing lines of code one by one into the computer, and you're saying, hey, please run this code for me. The computer is actually going to take that and compile it down to like metal machine code. We'll get into this in just a couple minutes here. And then it runs it, and then it says, okay, I'm ready for the next line. And then you can type the next line. And the lines can be very complicated. So you can say, you can say something like this, and then you've declared that these two things are now being concatenated and assigned to this variable. So if you look at this variable now, it stores the full value of everything put together. And this is running on every web page again, and it's not something you're going to interact with directly very much to build websites, and it's not something we'll be working with every day in the class, but it's sometimes very helpful to debug. You can also right-click, if you've seen this, and you go to Inspect, and then you have this other window here, which is HTML, and we're going to try to stay out of HTML and browser a lot this week because it's like this is diving right into JavaScript. So I won't go spend a lot of time on this, but this input here is part of the DOM. You've heard about the DOM. If you get the class, maybe this is a weird. It's all obfuscated because it's this. What does that mean? Okay, if I do document dot query selector and I do like class this thing, you can select both. But boom, there it is. So I can say dot inner HTML equals hello. Okay, that didn't really. Oh, sorry. It's an input, so it doesn't have inner HTML. I think it has a value. Magically, programmatically, I have told the website to change by using JavaScript code, very similar to the tip calculator, but this is how it interacts with the browser. And this is what the console is. The console basically is running the page, and you can interact with the page directly in real time by opening the console. Good for debugging. Not great for like actually developing because you want to save this somewhere. So that's it. That's the console. But that's in the slide, so just remember that shortcut or look it up. Okay, let's go on a tangent here and talk about what is a computer. Does anyone want to?
I do too, actually.
Okay, good.
The whole thing seems like
Magic, yes. Does anyone want to take a crack at like what? Don't worry about it. Like it's really hard to explain, and I only can do it because I've listened to other people with better explanations. But does anyone like what is it? It's electronic. It lights up. It does things. It makes noises. On-off switch. It's a. You're getting
involves electrons.
You're getting pretty close. It involves electrons. It's got switches. You're pretty close. It's lots and lots and lots of switches. That's how I would like lots of switches. This thing. Yes, but they're like they are literally little tiny electronic switches, which either allow current to go through them or don't allow current to go through them, and so they flip on and off. And there's billions of them. This thing, just the CPU in this thing has 4.3 billion switches in it, and the CPU stands for Central Processing Unit. That's like they say, oh, that's the brain of the computer. That is the part that flips on by itself. So you turn it on and it goes and it flips and it flips, and so many switches are flipping that eventually like enough of them flip to turn little lights on in the screen or to vibrate the sound speaker, or it's mind-boggling number of these little switches, and the speed at which they're flipping is absurd. You can't really relate to it. You can't really just intuitively understand it like that. Oh yeah, that many switches would read, but that's what it is. It's so many switches that they build up into all of these kind of natural interactions and consequences which you can understand at a higher level. It's sort of, yeah. There's a big difference in that they are electronic switches, so they're a lot simpler than a brain neuron or something. They're basically it's on or off and it lets current through or not. But yeah, I mean it's a giant assembly of switches which control a path of electrons. It's not totally similar because it doesn't. It's easier to understand what a computer is doing by looking at the pattern of the switches if you have enough time than it is to understand what a brain is doing. But it's good, yeah. Yeah. Okay, I don't. I think I get computers more than I get brains. But yeah, I've never done that actually. Okay. So anyway, I hope that's makes some sense. I hope that's helpful. There's another kind of switches. These are called RAM, random access memory. This is basically when the switches are set in different patterns, and when they're on and off in different patterns, they're storing information like numbers, like text, and there's just so many of them, billions and billions. You can store books, movies, video games, all of that stuff. And then the hard drive is really just the same kind of thing as the random access memory, but it's designed so that even when you power down the computer, the switches stay in the positions you set them, so that you can then read those positions later. When you turn it back on, you have to read them out of the hard drive and pull them back into the RAM. What RAM is good at doing is being very quick at reading and writing the positions of the switches. So that's a lot of switches. This is how Richard Feynman describes it. He says it's a glorified, high-class, very fast but stupid filing system, which is pretty close. Yeah, I mean that makes sense when you think of it like that. Okay, so this is like where the switches turn into meaning. This is sort of a little example. We have in the computer somewhere, just imagine these are like really tiny, like atomic scale switches. And they're the ones that are on are letting electricity through, and the ones that are off are not. You have 8 of them here. That's a byte. So each switch is basically a bit, and 8 of them together is a byte of data. And if this was in RAM, you'd represent this this data as the following sequence of 0 and 1. So when you see like binary code 0, 1, 1, that's basically a 1 means the switch is on, a 0 means the switch is off. And it is a direct correlation between the digit that you see in that and the actual physical switch in the computer. Not in JavaScript, okay? We'll get to that. But in C, in some cases when it's compiled down in JavaScript, yes, there's a direct correlation between the number and the binary digit and an actual physical switch somewhere in the computer. Now, that's great, but like you can't do a whole lot with just a bunch of zeros and ones. People don't communicate like that. We don't understand what that means. So what happens is there's encodings, and there's ways to turn these numbers into numbers, like integers. Now, if you were going to turn this into an integer, what you can do is you can say, this one represents 1, this one represents 2, this one represents 4, this one represents 8, 16, 32, 64. And you can say each of the positions represents a power of 2. And then you add them all together. So this would be 1 plus something. And that's the number. That's like a normal number. Now that's how you could store a bigger number, by just saying all of these switches together. This one you're going to multiply by 2, this one you're going to multiply by 4, and so on. The other thing you do is you'd store letters because you want text. And there's an older standard called ASCII. I don't know what it stands for, but it's for putting letters into bits. And ASCII basically is 7 bits. So this first one is gray because it was really only these 7. And if you had the switches in this position, the ASCII lookup there would tell you that's a letter. It's a capital letter A.
So ASCII is 7 and binary is 8.
No, binary is 1.
Oh, binary is 1.
UTF-8 or Unicode. So Unicode is basically a way to say, well, we need to be able to use Russian characters. We need to be able to use, all kinds of symbols and all other language characters, and all kinds of emojis even are those. So they were like, well, we're going to have thousands and thousands of characters, and you can't put thousands of different possibilities into just 8 switches. There's only, there's only 256 ways to switch 8 switches in different patterns, right? So you need more than that. So what Unicode is doing is basically saying, well, if this first one, it's always at least 8. And if the first one is a 0, then the rest of them are ASCII. So it's the same as the original. This one's still an A. It's the same. But if this one's a 1, that means there's going to be some more. So look for more stuff, and then you have more switches, and then you can encode all of this stuff. So this is all the emojis, all of the symbols, all of the other alphabets are encoded with 16 or sometimes even more than 16 switches. But it's all at the lowest level a bunch of electronic switches that are either on or off. Uh, yeah, so this is one byte because there's 8 switches. There's 8 1 or 0 values. 1 byte can store 256 different settings, different positions together. Now, a kilobyte is 1,024. It depends on the, if you're buying a hard drive, they use a smaller number because they, want to make money or whatever. But a kilobyte is 1,024 of these sets together. A megabyte is 1,024 times 1,024 of these. A gigabyte is another 1,024 times all of that. So it's like billions of these switches. By the time you get to a gigabyte, it literally means a billion bytes, which means 8 billion or more switches. Well, in each gigabyte, and this thing has 256 or something gigabytes, so it's quite a bit. And it's not easy to just intuitively think, oh, like that makes sense, like that big of a number means you can play a game or whatever. But that's true. That's how, yeah. They have a terabyte. They have a terabyte micro SD card now, I believe. Yeah.
You're right, it's not intuitive at all.
No, it's not. Yeah. It used to be, yeah. Maybe a exobyte or whatever the next one is big still. Anyway, okay. So if you are interested in this, if you want to play around with this, a really good way to do this is to go to the calculator app on your Mac. Every Mac has a calculator. And so you have the normal calculator here. I need a better way to switch between they're over there. Okay, cool. There's the normal calculator here, but you do splat 3, go to View Programmer, and then this changes to a programming calculator. Now this is good for working with bytes. You can click 10 here, and you can see it's still the number that I entered, which was 65. So if you click 10, you're working in normal numbers, base 10. There's 10 digits, and then you have 10. If you click 16, you're working in what's called hexadecimal. This means there's 16 different numbers. Like there's 0 through 9, but then there's A, B, C, D, E, F, and then 10. And that's actually 16 in the way that you are familiar with it. So it's a way to represent data in a different base. It's very confusing to think of if you're used to like math in base 10. So don't worry about it. Like don't worry. You're not going to have to really do this math very much. But you can see right here that well, you probably can't because it's tiny. But here it's actually listing out all of the individual bits that are set when you have the 4-1, which is 65, which is 0, 1, 0, 0, 0, 0, 0, 1, which is the letter A. So if you can represent the ASCII or the Unicode A by saying 0x, which is a normal way of saying I'm in base 16. So the numbers after aren't normal numbers; they're like computer numbers. 4-1, which is, if you do the math and work it out, that converts to the bits because why is that? Because 40 is 64, basically, and this one is the 64 switch, and this one is the 1 switch. So that's 64 plus 1 is 65. Converted into this thing, you get 41. Very confusing. So binary is actually base 2 because there's base 2 because there are 2 digits. The 0 counts, so there's 0 and 1. It's so 0 through 9 is base 10.
That's normal, what we use every
Right.
I'm just asking in terms of memories. Like
It
do you use base 2 or like the binary when you have when it's smaller?
yeah,
I don't know
so
basic.
I think yeah, when you're talking about smaller examples or you want a more literal version of what the machine actually has, it's in terms of switches that are actually on or off, then yes, you'd want to look at the actual ones and zeros here. But if you're like people who work in assembly and people who work on like computer chips where they're working with lots of these bits, but they're still working at the direct level of switches. They just want to use lots of them. They get very good at this. It's the same data, but they get really good and they understand what a 41. They will see in their head when they see OX41, they'll be like, oh, it's those bits. So like you get very good at it, and it's just a much quicker way. It's a lot quicker to write 0x41 than it is to write 001. All the ones and zeros. So it's really just a convention that is used by people who are usually very into like low level computer stuff. So it's not something that you're going to need in almost every case for almost every normal job, but it's something that exists and is how computers work, sort of. And that's the only reason I'm talking about it. So I think, okay, yeah, this is just sort of what I'm saying. We are working at a much higher level than any of these individual switches. The JavaScript engine is going to be setting all of them, managing them. You have to actually request a block of those switches from the operating system first, or else it won't let you access them. It will crash your program. Um, it requests the amount that you need. It gives them back when it's done. It's running not on the actual computer. It's running in what's called a virtual machine. So it basically says this thing is pretending to be a computer, and it's just a magic computer where you don't have to worry about a lot of the details. But behind the scenes, it's going to be requesting resources from the hardware and making what you have told the magic computer to do actually happen. So that's where JavaScript runs. It runs in a virtual machine. It does mean you don't have to really think about like how many bits do I need, how many bytes. You don't have to worry about the number of kilobytes that you're going to need for a string. You don't have to worry about if a string gets longer or shorter or an array gets longer or shorter, which is something you have to worry about if you're working at a very low level. And even we'll try to convert stuff between different types, like text and numbers. That's kind of controversial and that can get you into trouble. So like I wouldn't say that's like a good thing, but it's totally a thing you can do. Um, well, so a lot of times um, there's different schools in programming, and some people are like, well, it should be about as easy as possible to get anything you want to work, to just sort of try to interpret your intent and to say, this works as this way if I do it this way, so I'm going to do it this way, and then it's just okay because it works this way. And then there's like another school that's more like, um, you don't want that to happen because that means one of your assumptions was wrong or you might have made a little mistake or something. You want to know that. You don't want it to just be like, well, it's okay as long as it's this way, because if enough of those things accumulate, then you're going to have something will break and you'll be like, which one of it was though? Something will finally be too much. So it's that is one of those things where if you just sort of let the type coercion, it's called in JavaScript, like change your string to a number or change your number to a string or there's all kinds of crazy stuff. I think we're going to do some of those for fun tomorrow, but um, it'll work until it doesn't, and then it'll be very confusing. So, that's why it's not always a good thing.
And that's called type coercion.
Yeah, so it's dynamic typed in JavaScript. When it's trying to do something with a value, it will try to coerce the type of that value into whatever works, just because it's very much, that's how it was originally designed, to just keep working with, however it's going to work, just keep working. Okay, So if you're really into this, I mean, this is like the kind of the last we're going to talk about sort of computer details and switches and stuff. But if you're really like, oh, this is great, you can do these. This is actually extra credit today if you want to watch this. Whoops, not the end, not quite. If you want to watch this lecture, it's a little bit dated, but it's a good lecture and it's a very good explanation of a computer. You might have gotten enough from just talking about it like this, but you know, it's a very good explanation. So I'd recommend it. And then if you're really into this and you're like, I want to know how an entire computer works, everything for real, kind of, basically a computer from the 70s, but still, you can get this book and it will kick your ass. It is a very hard book. Anybody can start it, and like it's not something where, oh, you have to know everything to, but like it's going to take you a while to get through it if you want to. You know, maybe later if you're ever curious, what is a computer really doing? I really want to know more details. That's the book for you. All right, that's it. Assembly, yeah, or you know, electrical engineering type of stuff, or I mean, even if you just are curious and you're just kind of like, I'd like to have sort of a spider sense of like what's going on in there because it might help. It can sometimes help you be like, oh, this would be bad, you know, in a vague sort of sense because you remember something about what it's going to be doing, you know, or yeah. So there's a thing called a hex editor. So if you have like an executable file, I'm not sure what a hex editor on the Mac is like, but if you have an executable file or if you have a program that you're writing in like Xcode on a Mac, and you can set breakpoints and you can drop into assembly. Now they don't show you the ones and zeros. They show you assembly. Assembly is a bunch of three-letter words which mean like different things, and they're very low level, but they're not, you know, 10101, because a program, once you start talking about, remember the program itself is just a list of switches too, and it reads through them and does different things based on the switches that it finds. The CPU flips different switches based on the switches. It's crazy. It's totally crazy. But like, so at the level most people work, they work with these little three-letter codes which say, you know, do some action, move one value to another place, copy the switches here to the switches here, go to a different place and run the instruction there. There's all these, and it's a whole thing. But that's assembly, and you'll see that more often. You won't really see like binary data. You might see hexadecimal if you disassemble an executable file and you want to look through all of the bytes in it, the raw bytes, and that's how people like crack games and encryption and stuff. Like you just, you know, it takes a long time and you like look through the raw bytes and you figure out something, and you know, that stuff is beyond me. You know, I don't really do anything like that. It's cool to know about, but yeah. All right, so that's the end of the tangent. If everyone is done talking about the details of the computer, don't panic. This is like the slide. Don't panic. Programming can be very hard. You will get frustrated. It's normal. Learn to be comfortable with it. Just that feeling is a good feeling. You want to be comfortable with that. And that makes you most of the way to being a pro. That's like most of what makes you a programmer is the comfort when you're like in that mode. This is the quote. It's up to you to make the effort. When you are struggling to follow along, do not jump to any conclusions about your own capabilities. You are fine. You just need to keep at it. Take a break, reread some material, make sure you read and understand the example programs and exercises. Learning is hard work, but everything you learn is yours and will make subsequent learning easier. This is very true. So, you know, just all that stuff, don't sweat it. You know, this is sort of hopefully some serious smash over the head with some information, but we're going to go to writing some JavaScript now. Actually, we're going to go to wait, what time is it? Okay, so we're going to go to GitHub for the assignment today. And I guess I'm going to go to GitHub right now. Oh wait, I already have it. So did you use this Careers in Code classroom code base? Yeah, this was for, I guess we were, do you have GitHub? Does everyone have GitHub?
Yeah.
Okay. So, oh, well, look at me. I'm using the clicking interface here. I'm not even typing in the command line. It's bad. Everyone. Oh, really? Wait, so everyone's got the UI?
I sure wanted you to do like VS Code's built-in Git manager.
I've never even tried that. That's is that it's okay. Okay, so here's the how real hackers do it. Go to this thing. Actually, no, you don't even do that. We're gonna remove it, and then we're gonna say, this is the terminal. Has anyone used the terminal yet?
Yeah.
Okay.
Usually visual code.
Okay, so this is just the Mac terminal. It's, you run commands like git and stuff, but we're gonna say git clone. Is it hack upstate? Uh-oh, it doesn't exist. Well, I'm gonna have to look it up. Hack upstate careers in code classroom code base. Okay, I needed the HTTPS there. So we have this. Does everyone here? Let me. Sorry. What I'm gonna do is post this in the channel. This is what you have to run. Okay, so you have to do. Let me post the sequence of commands in the channel here, and hopefully everyone can follow along. Whoops, this is my work. Okay, so do.
Is in here, Jesse put up a message, hack upstate careers in code classroom code base.
Yes, that's the one. And so you can go to that and click, clone and everything. I'm just for fun. I'm gonna post the commands you can do it to get to a terminal and to do it in the terminal. So you do command and spacebar. Then you type terminal. You hit enter. Type terminal. Hit enter. And then do git clone that stuff. And if you set up git and you have it, that should get you the code base. And then finally, from wherever you are, it's going to save it to a folder in the current folder you're at in the terminal. And you can go cd that folder, which will navigate into it. Don't worry it'll just download it in your home folder, I believe, if you do those exactly in order. Has that worked? Sorry, I'll leave it up. The terminal should bring up a window like that, yep. Oh, sorry, mine is I'm in dark mode on my OS, so it's white with black text if you're in light mode.
So I did that.
Okay, so now do the CD.
Oh.
And you can probably type CAR and then hit the tab key, and it'll fill in the rest of it because that's the only thing that starts with CAR. Okay. The other thing we have to do today before we can get into this is we're going to have to install Nodejs. This is something we're going to be using later, but Nodejs is JavaScript that you can run from the terminal, just like this. No browser, no web page, no nothing, just JavaScript. And we're going to be using it later on for like making servers and databases and things. We're not going to get into a whole lot of like what it's for or what it is. It's actually the JavaScript engine from Google Chrome, pulled out of Google Chrome and just running in the terminal directly. But we're going to use it this week just so that we can run the example code, we can run assignment, and we can do the assignments and then run the assignments locally. No browsers, just pure JavaScript for this week. I think we'll get more back into the browser in a couple weeks, but this is sort of a, we're focusing on just the JavaScript here. So just go to the internet and look up nodejs.org. And there's a download button here. I would do the one that says recommended for most users. I think I already have it, so I don't know what this will do. I already have some version. Okay. Easy. Right, okay. Thank you. Yeah. So just type in the same terminal, just type node -- version.
If you don't see that, that means you have to download it.
Right.
Wait a minute, if you don't, if it says command not found, what?
That means you yep. Yep. Okay, so everyone get Node working. Shout out, get my attention if it's not working, if you need it. And while you're installing that, I'll just, well, you can type, so once you've finished the installer, you just type node -- version. Yeah, yes. Cool. So if you just run node here at the command line, sorry, does everyone have the repository? Sorry, I need to learn everybody's name. What's her name?
That's Caitlin.
Caitlin. Okay.
Me?
Yes.
Yeah,
Caitlin, you're not another. Kelly. Cashley. D something. Dakir. I'll get it. I'm gonna get a chart and everything. I'll get all of it by Thursday, and then I'll be gone for a couple of weeks. Whatever.
Do I want to keep the node installer when I browse?
You can get rid of it once it's done, but make sure you can run node space -- version. Yeah. Okay. Okay. To get into Node, you just type Node with no -- version, and you'll get this little angle caret here. Now this should look a little bit familiar. This is actually the same character from the browser console. This is basically telling you the same thing, like enter some JavaScript here, and it's going to run the JavaScript for you. So you can do 1 + 2, and it works like a calculator. No, you can do 1 + 2, and it still works like a calculator. So I think um, we got through a lot of that, pretty well. Everybody kind of followed along. I'm wondering if we should go into a little bit more on values and things, or do you want to just do more some programming exercises? I mean, what do people know about like different constructs like for loops and while loops? Not yet.
Just what I read about.
Okay, we're gonna do that in in a day or two, depending on how it goes. What about strings, integers, numbers? A little bit. Okay.
Like pre-code
Okay. So we're gonna sort of go through that just straight through tomorrow, as I think is the lecture. Variables, values, operators, all of the functions, the keywords, all of the basic stuff. But today, I think we're just going to kind of have some fun. Don't worry about exactly what the syntax is or what the technical names for everything or why it's breaking. If it breaks, don't worry about it. And the homework for today is there is a file in this repository. The assignment, there's a reading chapter, and then the assignment is there's a file in the repository. It has like a line of JavaScript, which doesn't really do much, but you can run it in Node. I'll show you how to run it. The assignment is to make it do something different so that when you save it, it runs in Node and it does something different. That's it. You can do whatever you want. You can change one character. You can change, you can try out whatever you want. And the real part of the assignment is getting used to making a pull request. So we'll go at the end of this. We're going to say you should fork this repository, change the file, and then make a pull request to say, here are my changes. And that is a pattern that I'd like to do for all 4 days of the week because it's a pattern that's very common in programming. It uses Git, which you've already used a little bit, but it's sort of getting to the next step of tracking changes, doing things locally, and then merging them with an upstream, what's called an upstream repository. You'll be doing that in whatever, it might not be Git, but that's a very common pattern at sort of any company. So anyway, so everyone got Node. You can run Node like this. You can get to the prompt here.
So what is this, like a virtual machine here in Terminal?
This is this. It behaves just about the same as the console in Chrome. Yeah, so this is an interpreter. This is called a read, evaluate, print loop. What it does is it reads what you've typed, it evaluates it, it runs the code, and then it prints anything that comes out of that. And did you use REPL it at all? This
What?
nobody used it at all. Okay,
Use what?
it's a website that you can do this kind of thing online, and it's named after read, evaluate, print.
What you just said about how this compares to Chrome Read.
Yeah. It's the same pattern of interacting. You get a prompt here. You can type in some JavaScript, just a line of JavaScript. It'll run it. It'll print whatever the result of running it is, which in this case is undefined. And then it will maintain the environment. So I can look at X here. X is been assigned the result of adding these two numbers. And it will stay that way as long as I if I overwrite it, actually, watch this. If I try to say X equals 1, it's going to say you can't do that because I said it was constant before. So that's a keyword. The reason sort of we're starting with this is because this is a nice sort of safeguard which you can use in more modern JavaScript to say you want to make it always explicit when your intention is for something to be a changeable piece of data, because changeable data is like very dangerous, especially changeable data that is global, that everything can see it and everything can change it. It starts getting very hard to keep track of. So the sort of way to mitigate that is to say, well, if you're not going to change the data, if all you need is some data that's the same for your program, make it constant. Make the computer tell you you're not allowed to change it if you try to change it, and then you have to go back and make it changeable if that is your real intention. So that's what that is. Now you can do like all kinds of other stuff. You can say for let is the changeable word. So if you want to change a variable, you don't use const, you use let. We'll go over all the keywords and everything tomorrow, or we could do it right now. Actually, you want to just go right into it? It's
If you
we
I'd
could.
rather have the definition before.
Okay, we can go right into it after the break, maybe. But let me. It's coming up in 5 minutes. Should we do 7 o'clock break or what? How are people feeling?
How would you do a full loop?
Well, I'm
Is
gonna.
that what you're doing right
Yeah, that's what I'm doing right now. So usually,
I was gonna say, if you can announce what your end goal is going to be before you start to type, so that way, because when you start typing and you're saying all this stuff, I'm still trying to
Okay.
figure out what you're trying to do. So if you say what you're trying to do,
okay.
then start the code.
So yeah, I guess that kind of spoils some of the surprise and delight sometimes. But you're right, and it's not worth it. Yeah, it's not worth it. So this is going to, spoiler, it's going to print out the word hello 1,000 times. That's what it's going to do. So, yes. And here it goes. Okay, this is going to start a for loop. We're going to declare a variable called I, which is going to start at 0. So a for loop has 3 parts inside it. It has, you set up something, you tell something what to do on every loop. Or no, sorry, you set up something. The second part is you say when the loop should be done. And the third part is you say what should happen every time through the loop. So
because I mean, I'm thinking it's completely different because if I may just do I instead of numbering loops that set amount and keep incrementing I.
yes.
But it's not that way.
No, this is more, I mean, this is the sort of plain vanilla for loop. There's a lot of other ways to loop through something in JavaScript, and the assignment tomorrow is going to be starting to get into some of those like fancier, newer ways. But this is sort of how you, do a very basic C-style loop. It's going to run fast. It's kind of unwieldy. The fact that the let is here is kind of a big deal because previously you would only be able to say var x, var y. You've probably seen that. And the problem with var is when you put it into a for loop like this, it exists outside the loop. It actually exists in the entire function. Wherever it's defined, it exists for that whole function. So I suddenly exist outside the loop. And that's always been the case in JavaScript. It's always just been a little random trap waiting to catch people. The let actually solves that because let is only scoped to the closest block. So a for loop, in this case, is the block. So the I will only exist for the purposes of the one loop. So anyway, back to the first part is
The FOR, is that the for loop you're just
yes. So
For every time that we're letting I equal something.
for
right. So
when you say closest block, what is that?
that's the for loop itself. So I'm gonna
itself. Okay.
here. I'll write the rest of it out, and then I'll talk about it a little bit, and then we'll run it.
Okay.
All right.
we don't know how to have fun. I'm sorry, but we work.
Okay.
Should we break so you have a minute?
No,
Get down to our level?
no, it's okay. We can, you know,
I wanna break the thought.
we have a. This is just a fun. This is just a fun. This is sort of like a break. So this second part, you're saying for these conditions. First condition. Create something. There's something called I. It's 0. Second condition.
Can you make that bigger?
Yes. Second condition, when should it keep looping? Like if this is true, keep looping. That's what I'm saying. So I is less than 1,000. Right? So if I is less than 1,000, keep looping. That's what I'm saying. Third thing, what do you do every loop? So I'm going to say I plus plus. Now you could say I plus equals 1. That's the same thing. You could say I equals I plus 1, I believe. These are all the same thing. You're saying add 1 to I and save it as the new I. Right? So we have those three conditions. Make the variable, when should it stop, or when should it keep running, really, and what to do each time. You open this curly brace, which says this is what you're doing every time through the loop. So every time through the loop, you're going to do whatever's in these curly braces. So we can say console.log hello and put a semicolon at the end just because it's a good practice. We could say 5 plus 5 if you want. That's not going to do anything. That's just an expression. It's valid JavaScript, but there would be no reason to ever do this. And I think Node or the browser might just say, I'm going to ignore that when it actually runs it because it doesn't do anything. It's just you're printing out. You're not printing anything. You're just putting a value into your code. But you can do it. It'll allow it. And then end the loop whenever you want to end the loop there. So again, this whole thing is the for loop. For is just a computer convention which is saying we want to loop through something under some conditions some number of times. The parts that are contained are the code that you want to run some number of times. So it runs this one, then checks all this stuff, then this one, then this one, then checks all this stuff, and then so on 1,000 times. So if we run it, it's going to print hello a whole lot. It's actually scrolling just like we wanted to. And then it's actually right at the end, it's going to print out 10 one time. That's kind of odd. Yeah. Well, no, but I put 5 plus 5. I put 5 plus 5 inside the loop. So you'd think it would have printed out after every hello. But no, I think the result of the entire for loop it considers to be 10, so it's printing the result, I guess. Kind of strange. Sure, yeah. So you can, let's do that. So so this is a thing in Node, very good to remember. You can press the up arrow to say I want the last line, and you're going to go backwards through all of the lines you typed. In this case, you kind of have to read the for loop backwards. It's weird, but you can press it until you get to this, and you're like, okay, I'm going to at least reuse this. This is nice. I don't have to retype any of that. So now in this loop, we're going to say, how about print? Okay. Yeah. So I forgot to do something here. We can do something here, and then we'll do another thing after. Well, let's say console.log. Been doing too much Python, like I said. Hello. Okay. Plus. Now, plus you can use to add numbers if they're numbers, but it will also put together strings if they're strings. So it's what's called an overloaded operator. It does two different things depending on what you're doing. If you start adding numbers to strings or strings to numbers, then really weird stuff can happen. So, again, that's what I was talking about with the types being like flexible and weird. Like, don't be surprised if you try to add this. If you add this, this will work. So if we do hello plus I is a number, but it's going to work fine because it's going to say, okay, I have a string and I need to combine it with this value. This is a number. The rules of the plus operator there are going to say, well, one thing we should try, the first thing it tries that works is to convert I into another string and put them together as one longer string. So it will just say, okay, well now it's part of the string and it's converted from a number into the actual characters that that number would look like when you print it out. They're two different things. So if we do this, we will see, you know, hello, and then whatever the value of I was on that particular loop.
Mine doesn't like the 3 dots.
I'm not typing those 3 dots, so it's just telling you, once you hit enter here, it's telling you that you're in the middle of a loop, so you just keep typing the rest of it, and then once you type this close thing, then it says, okay, this is one complete thing that is syntactically complete, and it can run it. Okay, so that's a cool thing you can do. Now we could also say let, because we want to change this variable. Let's see, let message equals hello. And now we'll go back to the loop 1,000 times, and we'll say message plus equals. Now you can do this plus equals things with the string too. You can use it to add numbers, you can use it to add strings, you can also do this plus equals. We'll say, let's add another hello on the end. And then let's not print it every time because that's a lot. But, well, it prints it anyway because that's the result of the for loop. So it's adding this hello every time through the loop to make a longer string. Now, if we did the same thing, but we said I, like we did before, we're going to get a whole ton of numbers. Wait a minute, what? Oh, because it's still got all the hellos from the last time we went through the loop. We need to reset hello. So this is what happens if you say, oh, this variable is mutable. We ran one experiment. The variable's still out there. It's still got this 1,000 hellos in it. And then we added more stuff to it. This is like one more hello and then a bunch of digits, which are actually counting, see? Sort of. But they're all just mashed together in a big long string. Okay, so should we do a break and then go into some of the details of this? Do you want to learn more about these?
So how easy is it just to reset it do you just type reset?
Well, yeah, I mean, you can do message equals hello again. And then if we did the loop again, you're going to see one hello and then all the numbers. Yeah, so because it's a let, because we've used that let message, then we're allowing it to be changeable, which is risky, but it's also would be the only way to use this particular way. Now there's some really way out there, more fancy ways to loop through, to make numbers concatenated, or to do something to accumulate a value, which is sort of what we're doing here. We're accumulating a bunch of data onto the end of a string that just gets longer and longer. Okay. Is everyone doing well? Like, should we go right into the next slides, or what do we do? We do a break? How does that work? Come back here in 10 minutes? Okay. Right. Okay. I just skipped like a whole bunch of it, so I'm going to do it really quick for the stream. Sorry, folks, on the stream, whatever that is.
It's probably gonna be us.
Yeah, okay. Well, let's do it again, just to be sure. This is day 1.5. This is our second lecture for the day. We're going to look at a line of code here. This line of code takes the value 50, and it assigns it to the variable called number of states. It's going to be a constant variable because we're using the constant keyword there. And this is a statement, so this will cause the JavaScript interpreter to do something, and the end result of that is that going to be there will be a variable that will exist, and it will have the value 50. Just getting into more details, a value. It's an arrangement of bits, of switches in the computer. This particular arrangement has a meaning, and it can be referred to by a particular name. It's not just switches on and off, it actually represents something. So in this case, in the code, in the JavaScript code, that could be the characters 50, which is a number. Or it could be a string, like a block of text, which you wrap in quotes, that says 50. Both of those might mean the same thing to like a person, but they're different ways of representing it. They're actually different data, but they might have a very similar meaning depending on the context. The variable, in this case, is the name that you've given this value. So in this case, the variable is this number of states, this word. Every value has a JavaScript type. Number and string are some of them. There's others. In this case, 50 is a number. This text here with the quotes, which says 50 spelled out, is a string. Now, JavaScript doesn't have any distinction between integer types and types with decimals in them. It's just called number. Every number is a number. And this is very weird and problematic. We'll get into that a little bit. Variables can be declared to be immutable by using this const keyword that we used, or you can declare them to be mutable, which is done with this let keyword. You want to prefer immutable if you're not sure, or if you know that the value is not going to change, especially. And variables can be declared function scoped and mutable at the same time with the old style var. So if you use var, then that variable will exist, like we were showing with the for loop, that variable will exist outside of the for loop. It'll exist everywhere inside the function that contains it. We'll get into functions soon, but a function is one unit of code that runs as one piece. So that, in general, I just wouldn't recommend using that. Like, I don't know of any really good scenarios where you need a variable to not be block scoped. If you come up with any that you think you need it, like, let me know, because I'd be curious to. There might be some strange use of it where you'd want it, but I don't think there is one. So I would say, in general, just don't use it. Yeah.
So for the mutable
You can reassign a mutable variable. Mutable means it can mutate, it can change. Immutable basically means once you've declared it, that name only means one thing in that scope, in that context. Now you could have it in one function, have X in another function, X, and they'd be different because they're scoped differently. They're in different places. But you know, the one particular declaration that is one of those X's is not going to be able to change. So it will always be whatever you assign it to at first.
So you want to declare it, you don't want to make it global, you want to change it. You want to change a variable.
Yeah.
I'm just trying to have it some of us. I just want to say I think you're.
If so, if you want a variable to be global, generally you don't want a variable to be global. If you want it to be global, you know, accessible anywhere, you're pretty sure you want to make it immutable then, because that's still somewhat safe. If you make a variable that's global, accessible everywhere, and mutable, it's gonna break something. It's because that's very hard to keep from breaking.
I'm not sure what you mean by global.
So we haven't gotten into scoping yet, but if you have a function which is a piece of your program, some variables will only exist within that function. So they'll exist for the lifetime of that function, and then they will go out of scope, and they will be basically deleted by the computer. Global basically means not in any particular function, available from anywhere in the program, if it hasn't been overridden in a locally.
So we should not use var.
Generally,
Generally speaking.
avoid using var. What you really don't want to do, let's see. Okay, I'll tell you what you really want to do when we get to it. Okay, so this is just something that I think like I just want to highlight or emphasize here, like the names of the things. This is not something which normally gets mentioned in instructions when you're saying, well, here's all the parts of the programming. One of the things that people mess up in the real world in programming jobs and stuff, almost more than anything else, is choosing good names for the variables. That's like one of the hardest things there is to do in the entire practice. There's a quote that says, there's two hard problems in programming. One of them is cache invalidation, which who cares what that is, and number two is naming things. That, it's very true. It's one of the hardest things there is to do. And like in general, I would just say like think carefully about the meaning of what you're going to name something, what that would look like to someone who isn't in your current state of mind. So when someone else comes and picks up your program, what they're reading, don't have the context of like the state of mind that you were in when you wrote it. So you want to make sure that it's not something that's going to be extremely confusing if you can help it. And if you have no other choices, I would say use a long, really clunky name which just is really unwieldy to work with. I would rather see that in a program than like a bunch of stuff named stuff or thing or value. Like, because this is worse because you're going to look at that and you're going to have to basically reverse engineer what stuff is and what thing is and why they're there and what they're doing. If you see this, it's going to be a whole lot of characters. It'll go off the end of the screen. But at least you're going to know that this should hold how many times the user has pressed enter. And maybe you can shorten it. Maybe if there's enough context where you think, you don't need to like put a whole sentence. You could say times pressed enter, or something. But it's not always going to mean the number of times the user has, So it's a balancing act. You have to balance the length of the text and the length of the words that people are going to be looking at and typing with the confusion from like having an X or a stuff or something like that.
Can you use comments in
Yes. Yeah, but
you don't want to
yeah, the thing about that is if you had to have a comment explaining what stuff is, everywhere you use stuff, it's just as good as having a long name for stuff. Yeah. So, okay, so back to this line of code. We're going to look now at the equal sign. So this is, makes sense sort of from math class, I guess, in algebra. Thing on the left equals the thing on the right, but that's not exactly what's happening here. There is this is an operator in JavaScript, and in particular, it's the assignment operator. So this is not like saying that this equation is balanced. This is saying the computer should take the value on the right of the equal sign and assign that to the variable on the left.
So just like the word is instead of equal.
Yeah, I guess like it's like saying is, but it's not like, yeah, it sort of is. You're telling the computer to do something here. There's actually an action which takes place before this line. There's no notion of number of states here, and after this line, this is going to hold the value you wanted it to hold. So there's a sense of action, but yes, you're saying, the variable number of states should be immutable and it should have the value 50. Yeah, right. It's somewhat ambiguous of a word, and let's not go there, I guess. But yeah. So that's the what the equals actually is. It's what's called an operator. It acts somehow on the code pieces around it, the values and the variables and the other things. There's other binary operators. What it's called in this sense, we're not saying binary in terms of bits, ones and zeros. We're saying binary really means two kinds of things. So in this case, a binary operator means it goes between two things. So the plus, for example, is a binary operator. Now that one is a little strange because, yes, this is a math equation, 1 plus 1. That's going to have the value 2. But you can also use it to put the strings together, like we saw. So the plus operator is overloaded to do addition of numbers, concatenation of strings, and you can use it to convert stuff into numbers sometimes as a unary operator too. I don't know. Anyway, it does some weird stuff that's not just adding, but most of the time you'll be adding numbers or concatenating strings. Does anyone know what that operator is? It's an OR. So this is the notation, which is once you get into like logic, yeah, this is a logical operator. So this says true or false. And when you combine these with this operator, there's no way to add they're not numbers, so you don't add them together. You're saying the value that results in operating on these two with this is true if either this one is true or this one is true. And in this case, this one is true, so the value of true or false is true. There's another operator that's 2 ampersands, which is the opposite. It's and. It says the value of the result of doing this operation is true only if both of these are true, and it's false if either one is not true. So those are both binary, though. They have values on either side. They work on two things, and you put them in the middle. There's unary operators. The exclamation point is another logic operator, but this one only works on one value. You put it right in front of the value you want it to work on, and it basically negates it. So this is called not, and you can read it as not false, which is very similar to saying true, or not true, which is similar to saying false. So just start, reading that as not, reading that as or. It is called logical for a reason. It makes logical sense when you use it in a sentence. This is another unary operator. It's called type of, and this basically will say take the value right after it and transform it into the value that represents the type of that value. So in this case, if you do type of 1, 2, 3, you're going to get number, because that's a number. If you do type of beer, you're going to get string. And that's, but it's operating on one thing, so it's called a unary operator. And then there's only one ternary operator in the whole language. But this operates on 3 different things. So it's called ternary. And the ternary operator is both of these. So you put 3 things together, and you say, first thing, condition, question mark, if it's true, it should be this, colon, if it's false, it should be this. So this would be this would store true or false. So you'd say is of age equals true, and then that would be true. This whole thing is going to evaluate beer in that case, because this is true, and therefore this operator altogether returns the thing on the left of the colon. It's really complicated. That one's a little out there. That's probably the trickiest one to get used to. But it's very useful when you don't want to write an if this, else this, and do it on many different lines. No, that's a variable. So this would hold something that evaluates to either true or false. And depending on what it evaluates to, the result of the entire expression that the operator is in is going to be one of the two choices. So it's operating on all three values at the same time. It's saying you have value A, you have value B, you have value C. The ternary operator says if A is true, then B, otherwise C. It's all together in one.
So you probably have a program where someone is typing in an age or is an age.
Well, it's not both. It's like
Yeah, so if you're 21, you can buy beer, and if you're not,
you can buy milk. Yeah.
So they put in that information, which is being stored in some type of variable, which is letting that person behind
Right.
the counter know whether or not I can get my wine cooler or back and get some Kool-Aid.
So it's like an option.
It's a condition.
Yes,
You have to
it's a-
meet condition
It's a condition that
to
is
be able to get.
Right.
is either
And
true or
that's
false.
just the variable where we
Right. This you need to see this in context. We'll do we can do a demo with that in context. It'll make sense. But that's sort of the most out there operator. It's the only one with three things involved. And yeah, just wanted to. They can work on 1, 2, or 3 values. Okay, so next thing, there's what's called an expression, and an expression is like when we were seeing the whole group of characters, 1 and then the plus and then 1. The 1 on the left is a value. The 1 on the right is a value. The plus is an operator. Altogether, that is what's called an expression. You're expressing some kind of, ultimately, a value. So you're saying this expression is going to produce a value. If you do the operation on the two values, you get the number 2. But an expression by itself isn't just a value. It's got many parts to it, which all are going to collapse into one value when the program runs. So, for example, let's just jump to Node, back to Node for a bit. If you do console.log 1 + 1, that's you're handing it an expression, and you're saying log this expression. Well, what it's going to do is evaluate that expression first, and then log the single value, because console.log is expecting a value there, not an expression. So it has to do the plus, it has to do the addition to combine the values, and it'll print out 2. So that's what it means. The fact that it's an expression just means it's more than one thing. It has to collapse to one thing when the program runs, and that's about it. And then a statement is basically a complete instruction. It's something that tells the computer to actually do something. If you just tell it 1 + 1, it's going to print 2, but it didn't actually do anything. It's just evaluating the expression that you handed it. If you have a program and you say, put a button here, respond to a click action over here, and 1 + 1, like it doesn't mean it doesn't do anything. So a statement is like actually causes something to change in the computer. And in this case, again, we're assigning the value 50 here to the variable number of states using the operator equals the assignment operator and we are declaring it as constant with this const keyword. Every statement, you should end it with a semicolon. Like JavaScript will try to do this automatically, but until you're really comfortable with it, or if you get a job and they're like, we don't use semicolons, just be like, sure, whatever, we don't use semicolons. But I would just say, just get in the habit of put a semicolon for now. Get used to it, and then you can ditch it later if you want. It's up to you. There's no agreement in the community over that, but all the instructors were like, yeah, we'll recommend semicolons because I use them at work. Most people do, I guess, in Syracuse. I don't know. Whatever. Don't worry about it. Okay. So the const and the let and the var and function and for and all of these special things that we saw, those words are called keywords. They are reserved by the language. The language says all of these words, JavaScript owns all of those words. You can't call a variable for, you can't call a variable const, because that will mess up the computer's ability to deconstruct what you're handing it. It won't know what is a variable, what is not. So these words are called reserved. They all have a special purpose. You can't use them as variable names. In JavaScript ES 2015 or ES6, all of these are reserved. Don't get freaked out by the fact that there's so many words, and you don't have to know what all they mean. I probably don't even know what half of these mean or what they're used for, but it's somewhere along the way someone in the language is like, we kind of want a feature that might use this word float or whatever. I think I know what that one means, but it's not actually being used a whole lot. It just ends up being reserved because of the process of developing the language. All it means is you can't make a variable called double. You can't make a variable called static. So those are special purpose. And it'll tell you usually, if you try to do that, it'll say that's a syntax error. It's not going to run. Await. That one's really cool. That one's like the coolest keyword in 2019. That one's like everybody likes await. It was started in C#, and then all the other languages are like, we gotta have await too. So everybody's got await now, and it's super cool, and everybody's really into it. It's really complicated. It's sort of a way to it's sort of sugar for a promise, and promise is sort of sugar for, or a nice way to express an action that happens later in time, a callback. Very functional programming, very out there, very cool these days. So that's what await is. You'll definitely see that later when you do like some functional programming stuff, probably, and Ajax probably. I think everybody's doing that now. It's a very nice way to do it. Yeah. Okay, so this is our line of code here, and I've just sort of marked, all the sections that are here, so you could refer to this if you're like confused about, which one was the value and the operator. So that's it. That's the semicolon. These two together kind of mean you're declaring a variable. And this whole thing with the semicolon is a statement. All right. So now there's numbers, there's strings, there's a lot of other stuff. Let's do some little demos of different types in JavaScript. I have vars here because I was like, I'm not sure if I'll get to the var thing, and the next slide is like, don't use var, make them constant, hooray. So that's all. So if we run this, we're gonna get the result. Now I'm gonna switch from using Node directly like this. So this is I was just sort of demonstrating you can do stuff, you can try things out really easily. You can do little calculator expressions. You can run little scripts. If you get really good at like, oh, I want to calculate the total of something real quick, you can use Node like that if you want. But it's a little bit unwieldy for writing. Oh man, I'm in Python mode. You do Control C, Control C, Control C, Control C. You don't really use this when you're writing a full program. You don't type it in line by line into a console or into a node like that because it's kind of ridiculous. It doesn't highlight the different colors. It doesn't give you any feedback on whether your program is correct or not, or like whether it's going to break or not. So you want to do that in like an editor for sure. You all have a VS Code running, is that right? So it turns out to be very good for JavaScript too. What I'm going to do is open VS Code. This is some work stuff. Okay, so if you open that folder that you git cloned, I'm going to there's a folder in there called module 4. Do you know how to open a folder in VS Code? You get the open folder. Yeah, right there. So there's a folder in this folder called module 4. Inside that there's a folder called week 6. Inside that there's a folder called day 1. Okay. So we're in the folder that we cloned from Git. So that's so yeah. When we run the thing, the stuff in here, this git clone step in the terminal, that should have downloaded a folder to wherever you are. Now, if this is like your first time using the terminal and you just ran exactly that, you should find it in your home folder, which is, so you do, let's see, open folder, and then there's a folder with a house icon, and it should have your username on it. So if you go to Visual Studio Code and click Open Folder, it should bring up the files. Open folders right there. And then there should be a. Oh man, there's no home folder anymore on Macs?
I don't have.
No.
Oh, that's great.
In your finder, if you go to help, remember there's a search bar, start typing your
I must have added that to mine. Okay. So I'm gonna try this. No, that's not gonna work. Okay. How about we try to clone this thing into your documents instead?
Can we go to the terminal in VS Code and say,
Oh,
and get it from there?
probably, yeah. Why don't we do whatever you're... Yeah, let's do that, because that sounds easier, and thank you. So it's a GitHub integration right here. Oh. Okay. I'm not sure what, I think I need someone to show me like what the Git integration looks like.
That was,
No source control provided registry. That's not, you've got it. Okay.
what was the name of that file? Like,
Well, so if you
that was no.
you open module 4, and then week 6, and then day 1. Index So, okay. So here's the other way that's pretty easy. And, this is like, it's sort of a faux pas if you're a developer to like go do this, but this is the easiest way. You click on this thing here. Whoops. You click on that link that I'm posting. This will open a GitHub page. You click this green button that says clone or download. You click download zip. And then it'll download right to your downloads. You go to your downloads and you double click that zip and it extracts. And then you go to Visual Studio Code and you say open the folder, and you definitely should have downloads in that bar by default. So there it is. That's the easy way. Definitely we need to get everybody to have it cloned on GitHub if we can, because we definitely want to be able to. So I think we'll switch to doing that right after some of these examples. Actually, yeah, we only have like a half hour, so we'll do a couple examples and then we'll switch to getting everyone set up with Git. And there's a couple of commands that you should try out tonight. Don't worry about if it's not coming to you, but we're going to try doing that for this week, just so you get used to doing some pull requests in Git. Okay. So inside module 4 folder, inside week 6, inside day 1, there is an index.js file. And this has some code that I've added here. And we probably should go run this from the terminal.
I don't have that index file.
Okay.
I'm hoping I have the right thing. I'm on module 4.
Do you
6,
have
day
the
1.
Git?
It says
Do
Git key.
you have the click the triangle next to the one
The triangle next to
in
it.
Visual Studio Code?
Oh, okay. Oh, there it is. Sorry. Okay.
Okay, so there should be, everyone should have that index file, hopefully. And we're going to run this file without going into the Node interpreter and typing it in line by line. We're just going to say run all of this. So whatever's in this file, we want to tell Node to run. And that will let us basically run just a piece of JavaScript by itself so that we can just do some experiments. And then eventually we'll get back into the browser and everything, but these are 2 environments where it can run. Plus the console, which is, again, not very good for much except for debugging stuff. So it's not where you want to write your programs. I have tiny text now. Here we go. Okay, so if you're in the terminal and you just did this and you didn't clone it, if you did clone it from GitHub, if you did those lines that are in the channel, you can do cd careers and then hit tab and it'll finish the whole thing. Mine is in a different folder. Hold on. Just ignore this part for 1 second. Okay, so if you do cd car and then hit tab, you should see that folder. If you did the git clone. If not, you have to do cd downloads with a capital D, and you can start hitting tab to complete what you're typing. As soon as you have the first couple characters, you can do cd dow capital D, hit tab, and now it completes downloads. You can say, now do car, hit tab, and this will show you the file you downloaded from GitHub. Or the folder you downloaded from GitHub, sorry, as long as you extracted that.
Is this in addition to getting that open?
No, you're all good. You got it open. Now, once you're in this folder, you're going to want to go cd again, module 4, then cd. So cd puts you into another folder. Cd week 6. And now I'm running out of space because the text is so small. CD day 1. And that's a whole lot. But now if you do node space, and instead of just running node like this, you do node index.js. That's the file we have in VS Code. If you run that, it's going to do what's in that file. So it's as if you pasted every line in that file into Node yourself, but you can run it all at once. So if I say I want to log instead of this, hello, all number of states, and then concatenate some more stuff, states. If I save this file and I go back to the terminal, I'm still in this folder, and I hit up for my last command and hit enter, it's going to print the new content. So it's going to do what the new file says. Notice how this one's yellow though. It's telling me this one's actually a number, and this one is white, which means this one is a string because it's converted the 50 into a string. Okay, I think we need to probably spend the rest of the time getting GitHub working if possible, and just sort of getting to this, because the only homework tonight is to get to the point where you can run this file from the command line and then change something and then run it again. And if possible, it would be cool to put it back onto GitHub, but it's probably fine to just submit it in person tomorrow if we can't get to GitHub. But let's try to go around and do get GitHub working for everybody. So what did, like, I thought everybody was on GitHub already. Okay, so you all have an account on GitHub. Does anybody have the desktop client? Do we want to use that, or you're using the VS Code? Have they been logged in VS Code?
Yeah, you guys have all mentioned your credentials, right? When we did it last week.
Mm-hmm.
Yep, so you guys can push a poll to get. Yeah, so they're all good in the
Okay.
VS Code GUI.
Okay. Cool. Okay. Well, let's go through these steps. Is everybody logged into GitHub? Do you see you're logged in? No, in browser. In the browser. Yeah. Okay. So we want to go to this link, which I pasted in the channel. Go to there in your browser. Make sure you're logged in up here in the corner. And then you want to click this button called fork. Okay? Everybody, can you do that right now? You might not see this because I actually have my work organization is linked to my same GitHub, so you might not see this. But I have to select I want to fork it to my personal account. It might just go to whatever this is. Do you see this? Mm-hmm. Okay. So now what this means is we've basically taken a copy of this entire repository and we've copied it over. Each of us has copied our own version of this into our own GitHub cloud. So we have our own copy of these files. If this repository changes, like when I upload stuff tomorrow for day 2, your fork will not have those changes yet because they're separate files now. But you will be able to pull those changes in just like any branch on Git. So this is just sort of like a kind of a branch on Git, but it's one that you've copied it, and now you have this on your own GitHub account, and you can change it now because it's part of your GitHub account. So so now it says Gus caused careers in code classroom codebase forked from the hack upstate one. Everyone should see that for their own screen name. And if we go into Visual Studio Code, oh, I need to set this up. Yeah, what do I do? Why doesn't it say what to do? Do you know how to set up the...
You shouldn't have to set it up as a workspace.
It's like no source control provider. Shouldn't I be able to browse my GitHub here?
Yeah. So when you clone the repo, it will initialize the file. So like it'll recognize your source provider's Git.
Okay.
So you have the folder open in VS Code?
Yeah. So the one I just downloaded, yeah, let me make sure I have that one open. So if you downloaded that folder, I guess, and you unzip that folder, you can open it here. And I hope this works. Yeah, this doesn't like it.
If you click on that black button next to source control, it asks you to pick a workspace folder to initialize Git repo in.
Oh, what does that mean?
Master just showed up. There you go. You're connected on the bottom, the little master thing.
Oh,
Yeah, the master thing in there.
Yeah, the lower left is where you can change your branch and everything. And then
cool.
it gives you a commit message.
But
where you
is
can
that
stage.
Gus's or mine?
Yeah. See, we got to make sure everybody's on their own fork
Yeah,
too.
right now it's on Gus's.
Okay.
Well, it's on the hack upstate.
Okay. So I guess. Okay. So here's what we'll do. Everybody is still on their fork page. You can see forked from here. Were you cloning stuff through VS Code? How do you clone it from VS Code? Or
Just open the terminal right
okay.
next
Okay. Okay. So I would say type wherever you are in the terminal. Get to a blank terminal. Type CD space and then the tilde key. So that's shift and the one in the corner there. And that'll get you back to your home folder from anywhere. What?
Oh, backslash?
It's the shift backslash or shift back tick. So it's the one right under the escape key.
Yeah, I did that.
Oh, sorry, you're still in Node. You gotta hit Control C. Yeah, you're typing JavaScript into there. Okay. So then let's type CD. Let's put it in Let's just put it in documents. Does that sound good? Capital D, OC, tab. It'll complete the documents. And now in here, you want to do what I pasted in this channel. So git clone this. Oh, no, you don't. Sorry. Don't do that. You want to go to your fork. You want to click the green button, clone or download. But you don't want to click either of these. You want to copy this. So click over here to copy it. So this is your own fork. As long as you see this forked from here, this is your own fork. You want to copy this here. And then go to the terminal. And you want to do git clone and then paste that. So see how mine has Gus Cost in it, because this is my fork of it. You should see your own screen, your own username in the URL there. Hit enter, it'll clone. And now this one in your documents folder is the real one. I just delete the other ones. So, yeah.
After we click on the port, what did you do? So this is mine.
So you want to click on the clone or download.
Oh, okay.
And then there's a little copy.
First, you need to go into documents.
All right, and then go back into terminal and paste this.
Now you can do git clone and paste the fork. Yeah, I mean,
You're in your desktop.
how do you do it?
Grange terminal. So this is Visual Studio Code.
Yeah.
Okay.
Do we want the whole folder or just? We just paste it?
Do ls.
So then we don't have to put anything else?
Instead of owning this,
So-
you put your folder.
Print
And then like whatever changes you're making,
Okay,
you're
so
not
you're
making changes to this folder to just only.
Do we need the whole folder or just the day one folder?
I mean, take the whole folder. It's up to you whether you want to put it on the whole thing. I would do the whole folder, then you have to go back.
Okay. It says no such allowed directory.
So then, so when you do
I
print,
mean,
You're going to 3, you're actually
you've done this,
PWD again.
right?
Do it again.
When you do a print
Now
out
you
directory,
see
Yes, you do it again.
Oh, get.
documents.
And then
Yes.
paste.
Yes. But let me tell you, you don't have to be in the
because
document.
then I just open
Keep
this.
it anywhere.
You can open it.
Yeah, right.
So now
If you have a
try
folder,
it.
then
Because the folder is not already there, it should come under your clipboard.
Gotcha, all right, good.
yes.
All right.
Okay. So
So the other folder I have, I can just take it out.
So I can get rid of this other, Cash, I can get rid of this other folder that you did for me, right?
Oh, yeah, keep that, yeah. Because this one was Gus, so.
yeah, I would recommend get rid of all that other. Sorry for the confusion, but get rid of all the other versions if you want. And this one is your fork. You can pull requests from your fork into the main one. You can edit it, and you can do all the Git things on it. So I would definitely work on this one. If you do gits, if you do cd and then that new folder, car tab, it'll complete it. You do ls, you see all the files in there. If you do git status, you'll see on branch master, your branch is up to date with origin master, nothing to commit, working tree clean. That means there's no new changes that you have remotely, and you don't have any changes locally that you need to update. So if you do git pull, that's just this isn't going to do anything. This is like already up to date. It just told you that. It doesn't need to pull in anything. But this is how you could get something from your own repository onto that's up on GitHub onto your local computer. The reverse, git push, is how you get something that's on your computer and ready to go up onto the github.com. So this will also say everything up to date. So neither of these do anything. If you do git you probably yeah.
His is in, all documents and code base. I think he can still write in his documents level.
Did you able to get that? Okay. Let me change my theme so that it's.
Oh. So, let's see, I'm in documents, and let's see, was I supposed to type git status?
What is that install support for JavaScript?
Uh,
See under tools and language, under customize?
yeah. That for JavaScript, anything you need pretty much is going to be built in already. So it's already this program is actually itself written in a version of JavaScript called TypeScript. It's it supports JavaScript and that those languages out of the box pretty well. Okay, so if you go back to the
And just, okay, I don't need to put a.
if you go back to the documents, or sorry, you go back to Visual Studio Code, you go back to Open Folder. Find your documents on the side where you just put the new one, and open the folder Careers in Code, Codebase, that one. So this one should be your fork of it, and it has all the same files. It should be a total copy of the Hack Upstate version. But the difference is now you'd be able to you're able to push to this repository. So if you say let's change the number of states to 55, because there's actually these are U.S. states, there are actually 5 territories as well. So I'll say 55 and save it. Now, if I go back to this folder in my terminal and I do git status again, it says you've changed something. You've saved a file and it's different. So it says the changes are not staged for commit. That means that it just knows that there's modifications, but it hasn't gotten them ready to say, this is, when you want to push a change to the server, you want to package it all up in what's called a commit. This is a set of changes that I'm making to the files in my fork, and when you're working with other people, these will be going up and down all day. You know, you'll have, oh, I have new commits, pull them down. Oh, I want to push some changes to the server, push them up. So these changes right now are not staged for the commit because they might be something else I'm working on that I don't want to put up. But if I want to say, okay, I would like to commit this change to my fork, I'm going to say git add, and you can put the name of the file specifically, or you can just say dot, which means this folder and anything in it. So you do that. Now if I run git status again, it turns green and it says changes to be committed. So they weren't staged for commit before. Now they're to be committed. They're still not committed, but they're ready to be committed. So if I say commit now, this will be one of the things I'm changing. That's all.
But why do you do it that way instead of just going this little thing, the weird scissors?
It's probably easier to do it that way, and I don't actually do this most of the time. I have colleagues who are like, the terminal's the only way to do it. But I actually use this thing, GitHub Desktop. It's like, you know, click everywhere and do this. There's a lot of nice clients for Git. I should get into the Visual Studio one, I think. But this is like what it's doing sort of to provide all of that. And this will at least get us working with the basics of just committing and then making a change, which is all we're trying to do today. So if I do git commit, you want to say -m and then say a message. Put it in quotes here. This will be the log message. It's a name for your changes. So this is when you're working with someone, you want to tell them I updated the font size to be bigger, or we've changed to a new convention for something. So this will just describe it. Include territories in number of states. Hit enter, and that commit is done. And it's got a little tag here, and see, it has the message that I typed. If I type now git log, this shows, this is the previous one that I've committed, and it shows that it's on the origin, means it's up in github.com. It's up in the cloud. And then this one is the one I just committed. It's not up in the cloud yet, but this is the latest commit, see? So if we do git push now, that's going to be uploaded to GitHub. So now if I do git log again, it's all three of these things. The local, the cloud, everything's on this latest commit. If I do git status, again it will say nothing to commit, everything's up to date. And if we go to GitHub, and if we reload the page, you'll see this latest commit here changes to what I just uploaded. So your own fork should change to reflect whatever message you typed in if you push that commit to GitHub. Now the last part of this, and when I get home, I'm gonna type up all of these instructions for the command line. You can do these in Visual Studio, but we'll get to that tomorrow if you need help with that. But the last part of this is to then say, I'd like to merge my changes into the repository. And in this case, we won't merge everyone's changes because everyone's going to change it in a different way, so we can't really do that, but we're going to just put what's called a pull request together, which says, I have these changes, and if these are ones that we want to proceed with, we can merge these from one branch into the other. So I would click here, new pull request. I'm on my fork page again. And you get this nice little set of drop downs. It says the base repository, see, is hack upstate / careers in code. The base branch is the only branch. There's just this master branch. And then the arrow is going in the direction I want the changes to propagate. So I've changed my fork of the repository, which starts, see, this is the head repository, and then it's, the branch, there's only one branch. So you can have the same pattern, you can have multiple branches within your own fork. So if you're working on something and you don't want it to be all merged together yet, you can branch it out as much as you want. But once you want to merge them together, you want to do a pull request. In this case, we're going across the fork. So that's why there's two different repositories here. And when we say create pull request, you can add a comment or whatever, and then you confirm it. And this here now is on the hack upstate GitHub. There is a new pull request here. Whoops. In this repository that's the hack upstate one, I've just opened a pull request saying, hey, include the territories and the number of states. It has the name of my commit. It pulled in automatically. And if you look at it, you can see Gus Cost wants to merge one commit into hack upstate master from Gus Cost master. So the colon means this is the fork on the left side, and then this is a branch. So I want to merge one commit into the upstream, the hack upstate version. And if you click here on Files Changed, you can actually see a very clear picture of what exactly I've changed. So this is where GitHub, I mean, all of this nonsense we're talking about, push and pull and everything, like this is why it pays off, is because when you're working with people and everybody's going off and changing and adding features and removing features, and they say, hey, I have some changes, watch out, like you were working on a feature over here, you want to be aware of what is being changed, you want to be able to review what is being changed. They want to be able to review what you're working on. So this is a way to basically allow people to collaborate and to say, if you merge this pull request, then these two characters here are going to change from saying 5.0 to saying 5.5 because that's the only change I've done. There could be many more changes. I could put a whole rewrite of the whole, reorganize all the folders, do whatever. But in a similar way, it would all show up listed here with the parts that are actually changing highlighted. So this is basically the reason everybody uses Git for stuff. It's because it makes it easy to understand and to manage the changes that different people are making at the same time. Okay, so I think we don't even have time for more activities or the types. We'll have to get into types, functions, and program structure tomorrow. And for tonight, I will post the set of things you need to do in GitHub to add your file, so open Visual Studio Code, make a couple changes. I'll post, you want to try to run them with Node if you want. Don't even worry about that part. We'll get into running files with Node tomorrow. Just try doing some changes and try committing them on GitHub. And then that's how the other the other assignments this week, they'll all be submitted like this as pull requests because it's a good thing to practice. So I think that's all we have time for today. Is this usually good stopping time? All right. Good. I hope people are getting something out of it. Oh yeah. It's